For the remainder of this section, we're going to be looking at another method of counting, and that's involving combinations and permutations. A lot of times people use these words interchangeably. However, there is a subtle difference and very important difference between them. So let's define them. A permutation is a way of arranging elements so that the order in which they are arranged is important. If you rearrange the elements, you create a new permutation. Where in a combination, if you rearrange the elements, you don't get a new combination. Okay, so let's say, for instance, I have three letters. Okay, so let's just say we have M-A-T. All right? And let's say I only pick two letters. So one combination or one permutation would be M-A, another one would be M-T, another one would be A-T. All right. If I were to flip those letters, let's say for instance I reverse them and just flip them all, this would be a new permutation. Okay, so all three of these are new permutations. However, they are the same combination. All right. So what this shows us is that there's a total of 3 combinations, but there are 6 permutations. Okay, that can be drawn from 3 distinct letters, and I pick 2 of them. There will be 3 combinations and 6 permutations. A lot of times we don't necessarily care about what the order looks like. A lot of times we just look at what the number might be. So let's say for instance we have n elements and I want to pick r of those elements from that set. The number of permutations is given as n factorial divided by n minus r factorial. The number of combinations, it's the exact same formula except now we're throwing in this r factorial. So the only difference between those two formulas is the r factorial in the denominator. And again, this just figures out the number of combinations and the number of permutations. Now, a question students often have is, when do I use a permutation and when do I use a combination? Generally, you want to use a permutation if every element is distinct. Okay, so for instance, remember we just had the example M-A-T, all right? And I was trying to pick letters from that. Then I would probably utilize a permutation for that. However, a combination is when there's some repetition because you can't distinguish the objects. So for instance, instead of M-A-T, let's say we had the objects M-T-T, where any 2 of the objects could be interchangeable with one another. Okay, it just fits a definition, but it's not distinguishable. I'm going to post a video on Blackboard for you to show how to utilize the calculator to compute the number of combinations and the number of permutations. Okay, it's actually pretty easy. But in your calculator, let's say for instance you wanted to compute permutation 2, 1. So in your calculator you would type 2, then you would type the math button, then you would scroll over to prob or P-R-O-B, and then once you go to P-R-O-B, then what you would do is you would select N-P-R, you would hit enter, you would type 1, and then you would hit enter again. Alright, so that's how you can try to compute that in your calculator. Again, I'll post a video for that. You could do the exact same thing with a combination. Instead of NPR, you would just put NCR. Alright? They should be right next to one another in your calculator. Now this is for a TI 83 or 84. If you have something different, then you might have to utilize a video online to be able to find that. So, all we're going to do for the rest of this section is we're just going to look at examples of utilizing combinations and permutations. So an example, consider the word ownership. Let's answer the following questions. How many ways can the word be arranged to create new words? All right, and when we say words, it's either real or fictitious. So real or fictitious words. All right, so it doesn't matter if it's a real word, it's more of just an arrangement. How many ways can the letters be arranged to create new words if the first letter must be E and the last must be R? How many different 5-letter words can be created? How many 6-letter words can be created if the first letter must be O? All right, so there's a couple ways we can do this, and I'm going to show you both ways throughout. For letter A, all right, one way we could do this is we know that there are 9 distinct letters. So in ownership, there are 9 distinct letters. As soon as we know that they're distinct, we're going to utilize a permutation. Okay? So there's 2 ways to do this. Okay? One way is, if you recall when we did the license plate problems or the alarm code problem, we could just have 9 spaces, and we could go ahead and start picking. All right? So in the first one we have 9. Now if we're arranging the letters, once we pick that letter, it's gone. So we could say 9, 8, 7, 6, 5, 4, 3, 2, 1. Another way to write that is 9 factorial. And if I were to compute that in my calculator, then that would work out to be 362,880. Now, another way to do this is by using a permutation. We could say permutation. There are 9 letters, and we are selecting all 9 of those. Okay, so I'm going to type that in my calculator. Hopefully it gives us the same thing. If not, then that's not good. So 9 math probability. And if you want to, you can do this along with me just to make sure you can do it. When I compute this in my calculator, I get 362,880. So that's good, because we should get the same thing from doing that. Letter B. How many different ways can the word be arranged to create new words if the first letter must be an E and the last letter must be an R? Again, 2 different ways of being able to do this. All right, we could do the 9-character method. Now the first letter must be an E. There's 1 way to create an E. The last letter must be an R. 1 way to create an R. And then finally in the middle, now we've picked 2 of the 9 letters, so there are 7, 6, 5, 4, 3, 2, 1. Or in other words, that could be 7 factorial. All right? I'm going to compute this, and I end up with 5,040. Another way to compute this using permutations is that we have 9 possible letters. Or excuse me, there are 7 possible letters. And the reason there are 7 letters is because 2 of them are already picked. All right, so if we're already picking, if some of them are fixed, okay, so these 2 letters are fixed, then we can't necessarily use them in the arrangement because they're already arranged for us. All right? Out of those 7, we're picking all 7 letters. So I'm going to go ahead in my calculator, compute 7 permutations 7. And I end up again with 5040. All right, so that's good because now we know 2 different ways to be able to approach the same problem. All right. Another example. This time, how many different 5-letter words? All right, so I'm just going to copy these down to a new line. So how many different 5-letter words can be created from ownership? All right, so we're not limiting anything. All right, so there's 2 ways to do this. Okay, so this is actually letter C, despite what this says. So this is C and D. All right, so for letter C, 2 ways to do this. Now we only have 5-letter words. All right, so one way to do this is we're picking 5 letters. Well, there's 9 total still. So that would be 9. We've picked 1 letter, then 8, 7, 6, and 5. If I go through and compute, 9 times 8 times 7 times 6 times 5. That's going to give me 15,120. Another way to do this is the permutation method. There are still 10 letters, or 9 letters, excuse me. So to be able to do this the other way, that would be permutation, and then we would have 9 letters, of which we are picking 5. Now I'm going to type this in my calculator. So 9 math permutation 5, and once again 15,120. All right, so again, 2 different ways to do the exact same problem. All right, finally, how many different 6-letter words can be created from ownership if the first letter must be an O? Now, if the first letter must be an O, okay, that's fixed. Recall that fixed letters or fixed objects do not factor into the computation of a permutation. All right, so here's how we can do this. We can either do it by using the spacing method. First letter's an O, which means that it's designated. Instead of 9 letters, now we have 8. So that's 8, 7, 6, 5, 4. I'm going to type that in my calculator. And that gives me 6720. Another way to do this is to say permutation 8. Now remember, that's 8 because there is one fixed object. All right, so there's one fixed object. Instead of 5 letters, we're going to have, instead of 6 letters, we're going to have 5 letters. So permutation 8, 5. I'm going to go ahead and stick that in my calculator. So 8 permutation 5, and that's going to be again 6720. All right, so hopefully this has been a good overview as to what a combination, what a permutation is, and then how to utilize permutations in some real-life examples. The next step we're going to be taking a look at is how do we use combinations.